Hey, what's going on, everybody? It's your boy Algebra coming to you live and direct from the studio, aka my living room. This is the fourth or fifth time trying to run through this video tonight. But anyway, we're going to try to go ahead and teach you one more time how to deal with a compound inequality. We're going to do 3 examples, and then you're going to have the opportunity to go ahead and go through and start your homework. Things that you should have done by now was 1, checked your answers on the board. Left the answers posted up on the chalkboard, 2 copies so that you can have multiple people looking at them at the same time. I also want you to check your work with each other to make sure that you are doing everything correctly. Once you've done that, we'll go ahead and get this video started. Again, doing 3 examples. Gonna do an or, and the and which problem. If you just catch what that corny joke was, that means it's an and problem, but it's sandwiched in between the last type of problem that we did. And again, once we're done with these 3 examples, you should be working on completing your homework. This last homework assignment, the one that you have just finished checking, is not being collected, but the one that you are performing for this evening will be collected for correctness for a grade, so it has to be right. And I encourage you guys to work together once you come to that point. So without further ado, as I watch the Broncos try to make a comeback against the Chargers, let's go ahead and get this party started. First example problem, 3x plus 5 is greater than 11, or 17x plus 4 is less than or equal to 21. So again, this problem is an or problem, which means I need to know all of the possibilities. You're not looking to overlap. You are looking to combine whatever your solutions are for each problem. So what I need you to do is solve first. This is a SADMEG process. It means you are using inverse operations in effort to isolate the variable in the inequality. First one says that x is greater than 2. Solving the second problem. Using again that SADMEG process, says that x is less than or equal to 1. This is an or problem. So the process that we outlined yesterday said, first, solve each inequality separately. The second step was to translate this into plain English. X is less than 2. You know what? I'm going to rewind for a second. Instead of just jumping into less than, I want you to understand that it is either less than 2 or greater than equal to 1. That is not telling you that both things have to happen. It's saying, I don't care if it's one thing, if it's both things at the same time, or if it's the other. Sometime, some way, the actual value is going to fit in one of these categories, possibly both, but definitely at least one of them again. So what this says, it might be, excuse me, I just messed this up. These numbers are backwards. It might be less than 1. It could be bigger than 2. Do you know which one it's going to be in? Not a clue. I don't have a clue. You don't have a clue. That means we need to have both answers, both possibilities. I'm messing this problem all the way up right now. This should not be colored in. Man, I should probably just start this video over, but I'm too tired for all of that right now. Here we go. Finally got it right. Now to turn that into an interval, which is always the last thing that we need to do, you would just take each one of these number lines, write out an interval for each one, and connect them with a U. This is your final answer. It has two different sections, but we have a way of connecting all of this information together at the same time. It is the union symbol in between. So an OR problem, it might not be connected. An OR problem says it is possible that you have an answer in one section. It might be in the other section. I just know it has to show up somewhere in this part that has been shaded. So after we've completed this first question, let's go ahead and try another one. This time we're going to be doing an AND problem. The question that I'm going to give you is 2 times a quantity of 3x plus 5, close it, minus 4x is greater than or equal to 21. Then the other thing that I'll say is that 2x plus 7 is, let's go with, is greater than 4x. Kind of numbers am I feeling? Minus 7. Kind of made this up off the top of my head, but let's see how it works out. First step, just like in the last problem, I need you to solve each one of these independently. That means distribute first. Boom, bop. Once you have done your distributive property, I want you to combine your like terms. Combine your like terms. Take some things across the river like this 10. And finally, isolate the x. This first thing says that x is greater than or equal to 11 halves. Solving the other side, I want to keep my variable on the right. That's just how keep my variable on the left. That's just how I like to do it. You could take the 2x over there. It does not matter. You're going to get to the same final result down the road. Take the 7 across the river. Notice that does not cancel out. That says that you should end up with negative 14. And finally, divide by a negative 2. If you divide by a negative, if you bring the extra negative to the table, that means that you should be flipping the sign. So we have two possibilities right now. Actually, not two possibilities, two things that are required to happen in this particular problem. What we're saying is that both of these need to be true. X is greater than or equal to 11 halves. And it is still less than 7. So what does that look like on a number line? That looks like a closed circle at 11 halves. An open circle at 7, and a connection between them. Bracket 11 halves, comma 7, parenthesis, done. So an AND problem says that I need to find what they have in common. These are the numbers in between 11 halves and 7 that will satisfy both equations at the same time. It's not pick and choose. It has to work in both situations. So let us continue. Last problem of the day. I actually feel like these are the easiest, but a lot of people think they're the hardest. Here we go. This is a sandwich problem. I say that so strangely because it has the word and in it, and that is all this problem really is a giant and problem. Here we go. What you should be doing is subtracting the 7 so that you can isolate the x. But when you do that, you should subtract the 7 from all 3 sections, not just the left and the right, all 3 of them. Don't forget about the middle. Second step, divide everything by 2. That is all sections again. Should end up with -2 is less than or equal to x, which is also less than or equal to +2. The x is between -2 and +2, which directly takes you to a number line with open circles, excuse me, not open circles, closed circles, because they are or equal to's. -2 to +2, both in brackets. Good luck on your homework and have a good weekend. Peace.